Hi, so we're going to look at the aqua paper question 9. This is actually a relatively easy question. We can do this without too much stress. Part A, show how the value of minus 5.1 has been calculated. That's the gradient, which is this value here. The gradient is change in y divided by change in x. Let me just sketch quickly a diagram of what we're looking at. So we know that gradient is equal to the change in the y values divided by the change in the x values. The change in the y values here, it goes from minus 6 down to minus 6.51. So that's a change of minus 0.51. And the change in the x values, it goes from 3 to 3.1 because h is 0.1. So that's over 0.1 equals minus 5.1. It's that simple. Okay, complete the third row. So here we need to just fill in the values of what we're looking at. So here x plus h will be 3.01, and the change in x will be minus 6.0501, and then we need to calculate the gradient. Again, that's the same basic principle. This is going to be minus 5.01 using the same idea. Okay, suggest the limit from this. Well, it's getting closer and closer to minus 5. So I reckon we're heading towards minus 5. It's just an idea. It's what it seems to be heading towards. So now, verify using differentiation from first principles that your answer to part C is correct. Okay, so we need to differentiate from first principles. I'm going to go ahead and do that. So I've copied down our formula, the function f of x, and I have recalled the formula that we use for differentiation from first principles. Hopefully you've noticed that there's something missing from this formula, which is the limits. I'm going to rewrite it with the limits. F dashed of x is equal to the limit as x tends towards 0 of f of x plus h, etc. Let me just tidy that up and write that more neatly. F of x plus h minus f of x all over h. Now, that's key because the limit thing matters and you've got to include it. Right, so going to substitute the values that we have into this equation. However, I'm probably going to miss out this limit thing every time because it just takes me a long time to write, but you must include it when you're writing. Okay, so f dashed of x is equal to f of x plus h, so x plus h minus x plus h squared minus, and I'm going to put brackets around this as well to keep the things in order, x minus x squared all over h. Expand brackets and simplify. F dashed of x is equal to x plus h minus x squared plus 2hx plus h squared minus x squared all over h. Going to tidy this up. Basically, if I just get rid of the brackets now, and then I can see what can cancel. So I get x plus h minus x squared minus 2hx minus h squared minus x plus x squared all over h. Let's get cancelling. X cancels with minus x squared cancels with plus x. Rewriting this now, f dashed of x equals, and I'm going to go back and put the limits in, which I had ignored. The limit as h tends towards 0 of h minus 2hx plus h squared all over h. That cancels. Gets me 1 minus 2x plus h. Just going to rewrite that with the limit again. So That's the limit as h tends towards 0 of, if I cancel that down, I get 1 minus 2x plus h, which as h goes towards 0 is equal to 1 minus 2x. Now, if the gradient is 3, that's dy by dx. That's the formula for the gradient. We were asked to check that when x equals 3, the gradient is minus 5. So we say if x equals 3, f dashed of x equals 1 minus 6, which is minus 5, which is what we thought it was, and we just need to say that. Okay, sorry that's a little bit messy, but I hope that helps.